Hello, and welcome to another episode of my devlog. I'm Chris, and this sprint was largely dedicated to the inventory system that's going to be in my video game. I've had a lot of ideas for how I've wanted to implement this, and I've been excited for a very long time to finally put these ideas to the test. So without further ado, let's just jump into what I got done this sprint. Alright, so as always, we're going to start by looking at the Trello board. So right here are the two items that we were able to complete. Fix player movement issues and upgrade inventory system. Wasn't able to really get into the player sprite this sprint. It's something that's always getting pushed off. I just didn't have time for that art side. But I was able to address these. So for the different issues, you may remember in the last video, I pointed out a few problems that I was having with the animations that I implemented. Adding 8-directional movement into the game proved to create some bugs. So I fixed most of them here. Controller compatibility. I don't have my controller with me, but take my word for it that that is now implemented. I had another bug where the door animations weren't working properly if I was walking through them diagonally. That's because the previous code didn't factor in diagonal movement. That works now. That was a pretty quick fix. And then the wrong idle frames for when you're using a mouse and keyboard and you move diagonally. We talked about that in the last episode, but I'll recap when we're inside of the game because it's kind of confusing both what the problem is and how I fixed it. This last component right here, diagonal movement speed is too fast. You may have noticed whenever my character moves at a diagonal direction, it looks like the character is sped up. Now, I don't know if this is a trick of the eye or an actual issue with the game at this moment, but it's something I want to look into and explore fixes if necessary. The big component to this sprint, however, was not the bug fixes. That's kind of boring cleanup work. It's the inventory system. So you can see I've added a bunch of different features that I was able to complete this sprint for the inventory system. I won't go through them right now in this bit because I want to show them to you within Unity. But I was able to implement a bunch of stuff and have a couple other items for future sprints to add. So let's just jump over to Unity and see what I got done. Pull it up right here. And first of all, let's look at the movement, because that's where we left off last sprint, and it's worth looking at a couple things. So I will point out that you can go through the door diagonally. That wasn't working. The character didn't recognize that they were opening the door if they were moving diagonally previously, but that works now. And as previously, you can be at an angle in the door. It all works great. Another thing that's worth mentioning is you may notice that the diagonal sprite character animations look a little less strutty as I had in the last episode. I wanted to address that. The legs aren't sticking so far forward. I don't know if I like this. I think I do. Still, there's a lot of character in the movement, which is good, but it doesn't seem so unrealistic at the angles. I have yet to work on these ugly frames right here. This was just another piece of the pie that I wasn't able to get to this sprint, but in later sprints, we'll be able to address that. Now, the big component here that I wanted to address, it wasn't mouse and keyboard, it wasn't walking through doors. The big problem I was going to face was diagonal movement with mouse and keyboard. You may remember in the last episode, if you haven't seen that, go back and check that, that whenever I would stop moving at a diagonal direction, the character would most likely end up facing not diagonally, but one of the two different directions that this diagonal movement is a composite of. So if I'm moving down and to the left, the character would either end facing down or to the left. And that's simply because we as humans lift up our fingers from keys at slightly different times, and the computer is fast enough to pick up on that. So I may think that I stop moving as I'm facing that direction, but really I've let go of the down key or the left key latest. There's a few different solutions to this, and most people that I saw online had solutions that were not ideal. It basically implemented lag into the game of once the player stopped moving, we actually wait for a second to check which direction they're supposed to be facing. But one person had an awesome idea, which is to calculate in a couple different axes. So I'm going to pull up the code and explain just what I mean here. So in Unity, there's two different sorts of input systems, input axes that you can look at. The raw axis in get axis raw, or the basic axis. And when I'm talking about axes, I'm talking about what is happening when you're actually pressing down on the keyboard. You notice these horizontal and vertical axes? that's referring to the up and down and left and right keys. So if I press up on the keyboard, then the vertical axis is set to 1. If I press down, it's set to -1. And the same goes for the horizontal axis if I press left to right. Now that's only true for the raw. If I'm getting raw axis, then it's either going to be 0, +1, or -1, depending on how I'm pressing them. If I don't do the raw axis, but have this, what it really should be called is interpolated axis or smoothing axis or something. I don't know why it's default, but basically what it is when you press down on the up key, it doesn't set the vertical axis to 1 immediately, but it gradually goes from 0 to 1 over a period of time. The reason for this is if you've ever played games, really realistic games like Assassin's Creed or something, where movement is fluid, when you start pressing forward, it takes a little time for your character to start moving. That's because in the real world, humans don't go from 0 to their top speed immediately. It takes time to get to there. And that's why this is in the game. That's probably why it's default. It takes time. So I start pressing right on the keyboard. The horizontal axis doesn't go immediately from 0 to 1. It goes gradually up. And when I let go of the key, this is the important part, it goes gradually down to 0. The brilliant person online, and I'll leave a link in the description for how, for their post on Stack Overflow for how they did this. They said when you think that the character has stopped moving, when the player has let go of all the keys, you don't just look at the raw axis that says it's 0 or it's 1. You also look at the smoothing axis and see, is it currently gradually going down to 0? If it is gradually going down to 0, that means the player recently stopped moving. You look at those current values, and from those values you can determine if the what direction the player was actually facing. This is very confusing. You don't need to get it, obviously, if you're not making a game right now, but I think it's worth showing how a little problem like this calls for a really complex solution that has to be run every single frame in the video game. So here's basically the code implementation of what I'm talking about. So I have X raw and X value, which is like the X smoothing value that goes between 0 and 1 and 1 and 0 gradually. And so the best way I can tell if the character should be facing up and to the right, I first check if the raw values are at 0, which means the fingers are off the keyboard. And if they're off the keyboard, then I want to look at the smoothing value to see, have they recently been taken off the keyboard? And if so, what directions were they facing previously, which I can tell by the smoothing values. As they're going to 0, they're either positive or negative or 0 currently. So basically right here I'm seeing is X and Y in between 1 and this little offset value that I'm calling sigma, which is like at 0.8. If so, then it's upright. If X is less than 1 and Y is greater than -1, and so on and so forth, if these values are in between 1 or -1 and this offset or this negative offset, then I can calculate if the player should be facing down right, up left, down left. It's really complicated. Maybe you're getting it perfectly, maybe you've just tuned out for this, but I think it's worth mentioning that problems like this, just a simple issue where you want the player to be facing the correct direction, even if the player isn't taking their fingers off at the right time, calls for really complex solutions that aren't always apparent and can be pretty computationally expensive for the computer. At least these are just if statements. It's not too hard for the computer to process, but it does take a little while for me as the developer to implement it. Okay, cool. Now we've addressed that issue, and I'm really glad with the solution. It makes the whole thing look very smooth. Now let's move on to the meat of the subject, the meat of the sprint, which is the inventory system. Alright, so you may recognize these packs from a previous episode. Basically, they're concept art of how I want the inventory system to work. I want you to be able to move in and out of different storage devices, such as a backpack, a messenger bag, or a big wicker basket. And there's different sizes. There's large inventory slots, medium, and small. And basically my idea here is to address an issue that exists in a lot of video games where it may be called an adventure video game or an RPG game, but really it's all about looting, getting items, and getting as many items as you can and as much money as you can. I want this game to be about immersion and adventure, not items, and how you create your inventory system is going to tell that player how items are going to relate to them in the game. If you give the player a massive inventory space, then it tells the player from the get-go they should collect every single item they have the ability to pick up. If you give them a very small inventory space, then it gives them the idea that they should probably value every item they can find and have to think very critically what items they discard and what items they keep. And if you give them a small inventory space but allow them to increase it over time, it's much the same problem of the first issue. It tells the player, yes, you don't have much inventory space right now, but the goal is to increase it so that you can hang on to every item you find. The example I have in the real world is, let's say you're walking between classes when you're in school and you see a little balled up piece of paper on the ground. Do you just pick it up automatically and put it into your backpack because you have infinite space? Of course not. You move on, you know what items are important to you and what aren't, and you're not worrying about those. But in most video games, you do pick it up, you do hang on to it, and it creates clutter in your inventory space. It means you have to deal with tedious inventory management later on, and you have a bunch of things that you don't want, ultimately. I want to create an inventory system that discourages that mentality. So which is what I'm going for here. Inventory as storage, not simply space. All right, so talking about that, I've created a few different items. So first of all, a little piece of fruit. This was going to be an apple, but then I started to realize that it looked more like an orange, so I turned it orange and didn't look quite like that, so I'm just calling it fruit. A book, and then a wood axe. And so basically, these three items represent the three different sizes that could be in the inventory slots. These are just going to let me be able to test out my work as I go along. So if I come in here and hit play, then, as you saw, all the components still work, but if I hit I on the keyboard, my inventory comes up, and I have a few items in them. This is all pulling from my previous implementations of storing data within the actual computer storage. And you can see when I scroll my mouse over an item, it tells me what it is underneath my mouse. And also you can drag and drop these items. It turns a little gray, and you can drop an item into another slot. You can't drop an item into a slot where another item is, but you can drop items into slots that are either equal to or bigger than them. So I could put the fruit in the large slot if I wanted to, but I can't put items into smaller slots or into slots that already have an item. Now, this is a lot of different little components that I have built in here. There's a few more things that I want, such as I want to be able to stack items, and I would also like to not have one piece of fruit taking up that entire inventory slot. I wasn't sure how I wanted to address this previously, but now that I'm seeing it, I really feel like you should be able to have multiple small items in a large slot, because this feels kind of ridiculous, and if the player has just a bunch of small items on them, they feel like the game is forcing them to waste space, putting a small item into a larger slot that doesn't really call for it. So I want to rethink this functionality as well as add stacking functionality, but for now I'm pretty happy with this. And so you can keep walking around, you can pull up your inventory slot, and this just works right out of the box now. There's a few things I want to add that I haven't mentioned here. So currently saving the game, yes, it says it saves, but it doesn't actually save your inventory. I'd like to be able to discard items, I don't know, dragging them off or not. And I would also like to be able to show a little icon around an open slot when you drag an item onto it, showing that you can actually drop it here. So instead of having to let go of an item to find if that works, you can see just like a yellow outline or something telling you that you can drop that item. That and a few other things. The inventory system, like I said, tells the player a whole lot of how they relate to items and items relate to them in the game. And I'm going to put a lot more work into this inventory system in the future. This is just an introduction to the inventory system, getting it up and running so that I can spend a lot more time on this. I really want to nail this down and get this correct so that players understand the relationship they have with items, so that this doesn't become a looting simulator or a hoarding simulator, but becomes an immersive adventure game as I intend it to be. So that brings us to the end of another episode. I was intending for this one to also record a bit of my process for both programming and especially art, so you could see what that looks like and see my process on the fly, so that you have a little bit of behind the scenes of what's going on. I never got around to doing it for this episode, but hopefully in the future you're going to be able to see that. If you liked this episode, please give it a like. Thank you so much for watching, and I will see you in the next one.